Remember when you were a child, and as you got older, you realized that your clothes were too tight because you were growing up and getting bigger? It's common for data warehouses, especially ones that are on premises, to encounter the same kind of growing pains, which is why so many businesses choose to migrate their data to the Google platform, where the growth potential is limitless. But migrations without loss of data can be tricky. So let's look at the most important aspects to consider. In this course, I'll explore the intricacies of planning data migrations, where you'll learn to create robust migration strategies. Discover the importance of validating migration plans, ensuring seamless transitions. I'll dive into the specifics of services like the Database Migration Service, Google Transfer Appliance, and BigQuery Data Transfer Service. Uncover the art of integrating other services harmoniously within migration workflows. I'll cover how to validate your data migrations using powerful tools like the Data Validation tool. Lastly, I'll address critical data governance concerns during the migration process. This course equips you with the knowledge needed for successful data migrations. This course is one of a collection that prepares learners for the Google Professional Data Engineer exam. In this video, we're going to analyze current stakeholder needs, users, processes, and technologies to create a migration plan. Let's first understand, how do we plan data migrations? Well, first what we want to do is we want to first start with the needs of the user, and this is where we have to do an assessment and figure out an audit of what processes and technologies that we're going to use to solve the problem at hand. And this is where we want to get to a plan that's going to get us to a desired state. Now, this is after we have the assessment, we have the plan. Now we want to start executing the plan. So we have to now do the migration. And this is where we'll be able to transfer data. So using this, for example, the BigQuery Data Transfer Service or Database Migration Service to get information from one location to the other, which is usually a cloud or BigQuery table. Finally, when this data is migrated, the last step we have to do is actually work with validation. So now that I've moved my data, it's all in the cloud, we now need to check to make sure that there's been no bugs, no errors, and that all of our data is intact and in the required place that we've assessed during the assessment. Now let's start with database migration. Now there's a few different types of migration types. We've got database migration, and this is usually referring to moving data from one database vendor to another database vendor. Or if we're trying to upgrade to a database software to a newer version, the data format can vary between vendors, so transformation process may be required, and this is where we'll have an ETL to do this. Another thing that we might use is called a storage migration. This just means that we're going to transfer data from an existing repository to another. Often, it's a brand new repository with nothing in it. So the data will usually remain unchanged during this storage migration, and it's just meant to upgrade to a more modern technology which can scale data more cost effectively, and it could process data faster. We have the business process migration. This involves the transfer of databases and applications containing data that's related to customers, products, and operations. So this means that we are going to work with data that often requires transformation because it's moving from one data model to another. These projects are triggered by a company reorganization, a merger, or some type of acquisition. This is usually where it's done. Another thing that you might look at is application migration, which is moving software applications such as a CRM system, so like HubSpot, from one computing environment to another. And so the data will usually require some type of transformation because it's moving to a brand new application vendor, and it involves transforming from one premises to a public cloud, or moving from one cloud to another. This is where we'll use it. Finally, there's the big one. This is the cloud migration. It involves moving data, applications, or other business elements to a cloud computing environment, and this is where we'll be working with a cloud data warehouse typically. It can go from a locally hosted data center off to the public, or one or more cloud platforms to another. And then we have something known as the data warehouse migration assessment and planning step. This is our very first step, is where we need to assess and clean the source of data that we're going to be working with. So this is usually the beginning of our planning phase, is just understanding the size, the stability, and format of the data we're going to be moving. And then we want to be able to design the migration plan and notify all key stakeholders of what's going on. So now that we understand what data needs to be moved, what kind of data it is, details of all of our technical architecture and processes, things like budgets and timelines are in place. Now we have to notify the key stakeholders. And this is really important so that we get buy-in during this migration step. Finally, we want to determine initial processing and storage capacity. So what we want to do here is we want to build the solution. And so this is where we're going to start coding the migration logic that we're going to be designing and extracting this transform and load data into this new repository. And so this is where we're going to need to identify the initial processing and storage capacity that we're going to need. So if you're working with a very large data set, you might have to consider splitting it into sections and then build and test section by section, depending on how large this is. Finally, we have the data warehouse migration assessment and planning, which involves things like considering our future growth needs. So exactly where are we going to be in 5 years from now for this data? Is it possible that we need this to scale? Are we going to take more data? What exactly is needs of the organization? And then we have to have some type of strategy to develop a future state strategy and vision to help guide our design. So this means that what exactly we kind of have to be a bit of predictors here and think, where's the organization going to be in 5 to 10 years? And can we plan things for this? Can we plan some data that we have to worry about? Exactly what type of data could we be seeing in 10 years? What amount of data? Will our user base exponentially grow? How will that affect the current architecture that we have in place in the cloud? All of these questions are something that we have to be cautious of. So when we're making decisions, that we are aware of the possibilities in the future. Now, data warehouse migration, this means that we have to validate the data migration process and our timelines. And so we, as the cloud foundation is being set up, we have to consider things like proof of concept so that we can validate this whole process. And then we have to identify automated tools and services that can be used. There's no sense in reinventing the wheel. So I like to look for automated utilities to help with any required code migration. And we need to maintain some data syncing between the legacy and the new data warehouse. So this is where we want to use critical business processes to help keep the project on schedule. And so typically what will happen is as we're building this new data warehouse, we keep the legacy data warehouse up and running and in sync with each other. When the new data warehouse is ready to go, what happens is it's almost like a blue-green deployment where the old one gets deleted and the new one takes its place and it starts doing all the heavy lifting. So there is a period of time where we're going to be using both. And then after a while, it's kind of like one turns off and the other keeps the connections alive for it. So we want to use enterprise level tools to work with both of these environments, both legacy and the new data warehouse environment. And this is where we're going to kind of keep the data sets in sync with each other. So data warehouse migration, again, means that we need to identify some of the access patterns and how BigQuery can be used to replace them. So this is important for this. And then we have to review the code integration and data model conversion processes that we're going to be using from one legacy system to a new one. Exactly how is this going to be transformed? And then we want to be able to fine-tune the capacity forecasts using BigQuery as well. We also have data warehouse migration, validation, and testing. So now that this is all in the cloud, how do we keep this? How do we know that it's worked properly, that all our data is intact and it makes sense? So we have to use tools for automated data validation. So this is where there's some type of AI that kind of does some intelligent data validation for us, does a check. We can also review the database schema and the data ourselves. So this is where it's part of our scope to make sure that, okay, the data is mapped correctly from one location to the other. We want to implement continuous validation processes so that as we move data from the source to target systems during migration, we get constant logs of any errors that pop up so that we have an idea if something's not valid or not. And we want to basically determine the amount of required testing based on the migration complexity. So the more complex the migration, it'll be driven by the complexity of our applications consuming the data and rate of change of those applications and how much data is actually going to be coming during that process. This is really important. So you almost have to do this in an incremental step-by-step fashion to be able to understand how your data is being transformed and stored in this data warehouse. So that is a little bit on data warehouse migration, validation, and testing in Google Cloud. In this video, we're going to ensure that the most important questions are being answered when we're planning for a data migration. Let's first understand validating a plan for our migration and what it means. So when we're validating a plan, we want to make sure that for each migration, we develop what's called a rollback plan in case of issues. This is basically a strategy that we can implement if that we need to recover from these issues that come up. Like this is if we created a new process, we started the plan, and then we started immediately seeing regressions. Once we have a rollback strategy for each step of the migration plan, it allows us to avoid losing time during an outage. So I ensure that my rollback strategy is working by periodically reviewing and testing each rollback strategy, and I can set a maximum allowed execution time for each migration step. So if the migration step is taking too long, that means something's probably wrong. I can automatically roll back to the previous state. Also, avoiding large-scale migrations and perform gradual rollouts and deployments is crucial. So to reduce the scope of issues and problems that might occur during the migration, you want to avoid those large changes. And so this way you can design your plan to not do the deployment all at once, but to gradually deploy the changes from one state to the other. So I can plan for gradual deployments and configuration changes. If I plan for gradual rollouts, it lowers the risk of unanticipated issues, and it's going to minimize the number and the size of those changes. So it allows me to actually see what change was causing the error rather than having 10 changes all happen at once. I get to alert operation and development teams of the migration timelines. So this should be done ahead of time before you even begin the migration. You want to alert the teams that are responsible for things like infrastructure of both the source and target environments. So that way they can properly cover those time zones and they cover multiple consecutive shifts because they might be unable to resolve issues during a single shift. So teams are prepared to collect detailed information about the issues they might face. And this collection provides engineers on the next shift of a complete understanding of what the previous did and why, so you keep logs of what's happening as this migration is happening. We want to validate a plan for our migration, so remove any proof of concept resources from the production environment is crucial. Don't have any POC code at this stage. And then you want to make sure that you define the conditions that need to be met to retire the source environment. So all workloads, including their backups and high availability and disaster recovery mechanisms, are migrated to the target environment. Another thing that we can do is we can assess the current workloads in our environments. So we ensure that the list of workloads to migrate are current and they identify any gaps. We want to determine which workloads can handle downtimes. So some of them can have some downtimes and the maximum length of time that those downtimes can be. This way, migrating workloads while experiencing zero or nearly zero downtimes is harder than migrating workloads that can afford downtime. So maybe some of them can be off for maybe a few hours while this migration is happening, which is good. It saves us some resources. We want to determine the workloads that support clustering and redundancy. If a workload supports clustering and redundancy, I can deploy multiple instances of that workload across different environments, such as the source environment and the target environment. I can determine how workloads configurations are updated, so I can assess how I update the configuration of our workloads, and then I can create multiple assessment reports as well. So during the assessment phase, it might be beneficial to generate more than one assessment report to account for different scenarios. So maybe I'll generate a report to take account under different load profiles for our workloads, such as at and off peak times to see how this workload is going to perform. And I can also assess the data processing pipelines as well. So there's a few different things I need to ask my questions about, which is, are my resources correctly sized for the migration, for the data and the speed of which I'm expecting it to operate? What is the migration timeline? How much time is required to migrate the data from our workloads? And can the target environment accommodate the full volume of data, which is crucial? And how do workloads manage our spikes? So how do they behave when they have to accommodate spikes in demands or spikes in the amount of data that they're producing in a given time window? Do spikes cause performance problems? How much of those, what does those performance problems look like to the end user? Do workloads need initiation time? So after our workloads start, do they need to ramp up to the expected levels of performance? Sometimes that does happen in the cloud. And once we have these questions answered, we can start looking at validating workload failure modes. So one thing that we want to do, we can validate workload failure modes. So one thing that we want to do is what happens if there is a network issue. Sometimes our networking, we could lose some internet or some power might be lost. What happens then? Can we account for that? Is a workload able to recover gracefully if something were to go wrong? Another one that we can provide is, does the workload fail if it runs out of resources, which is a very important step. So we can also validate workload failure modes as well. What happens if two workloads are duplicated is a major question that we need to know. Sometimes we have to make sure that in the events that two workloads are duplicated, we might have to tear one down before we start creating the other one, which could lead to downtimes. What happens if task doesn't run on schedules, which is really important. And then what happens if two workloads are processing the same request, which can happen? Does that lead to some redundancy error? Another thing that I want to sort of add here is monitoring our environments once they're created. We want to observe how our source and target environments are behaving so that we can help diagnose issues as they occur. So a monitoring system to gather metrics is important, as well as observing operation workflows by using a logging system so I can actually assess what's happening in maybe Google Cloud logging. And there's configuring an alerting system so when migration issues do occur, necessary stakeholders are notified of the error. Finally, there's migration postpartum. So to manage the migration, we have to review the performance of the migration to gather information that you can use as a retrospective after it's all complete. So we want to review the time taken for each migration step. We want to identify any deviations from the planned schedule. And we want to determine if the plan was complete and accurate, if we missed anything. And then finally, we want to be able to identify any negative events that occurred during our migration. And so we want to take note of this because the next time we have to do a migration, we can start to kind of fill in those gaps so that these issues don't arise next time, if there were any issues at all. So that's a little bit on how we can ensure that the most important questions are being answered when we're planning for a data migration in the cloud. In this video, we're going to describe the requirements and use case for leveraging the Database Migration Service. First, understand what the Database Migration Service is. DMS, or the Database Migration Service, provides support to migrate MySQL, PostgreSQL, SQL Server, and Oracle to Cloud SQL or an Alloy database. What this means is that the primary database is going to be moved to the destination, and the new destination is going to become the new primary database. This allows us to streamline things like the networking flow, manages the replication process, and monitors the migration operation as it's ongoing. The Database Migration Service features include things like simple processes for migration of MySQL, PostgreSQL, SQL Server, and all Oracle databases. And they have AI-powered assistants that could enhance the Database Migration Service and process for us. Now, the migrate Oracle's workloads to Cloud SQL or Alloy DB is crucial here. This is where we can actually take on-premises Oracle database or some type of Oracle database that's stored in the cloud and move this over to Cloud SQL or Alloy DB. This leaves us with a nice serverless experience. This will perform any type of serverless data migration with very minimal downtime. And so these makes it very easy to use for us. And it's actually built in with Gemini in the Database Migration Service so that we can have AI-powered assistance. With the help of Gemini in any database migration service, I can review and convert database resident code, just like stored procedures or triggers and functions, to any type of PostgreSQL compatible dialect. And data is going to be protected during this migration and at rest so that security is going to be paramount here. I can rest easy knowing that this database is either contained properly, at rest in the destination, and during transit. So what you'll notice here is that the Database Migration Service benefits include this simplified migration with just a few clicks that can be done in the cloud. You'll have this Gemini-assisted conversion process that's ready to go. And it can reduce migration complexity and means that we can reduce cost as well. Now, there's going to be very minimal downtime. So this fully managed service migrates our database with very small downtime because it's all serverless. These migrations are highly performant at scale, and they can take an initial snapshot followed by continuous data replication as new data is going from the source system. It'll also go to the destination system. We can migrate to Cloud SQL or AlloyDB or any type of PostgreSQL services, including things like availability, stability, and security. Here are some migration types as well. So we have homogeneous migrations. So for homogeneous, we have this like-to-like migrations. So if I'm working such as MySQL to Cloud SQL for MySQL, PostgreSQL to Cloud SQL for PostgreSQL, you see how if I have a MySQL server, I can use MySQL in the cloud. So that's called a homogeneous migration. And so this means that if I'm working with PostgreSQL or MySQL, I can set up the migration so that a replica instance appears in the Cloud SQL instance, and this will be attached to the source that was set up. And then there's heterogeneous migrations, which means that the source and destinations are different dialects, such as if I have Oracle to Cloud SQL for PostgreSQL, this migration leverages what's called change data capture based replication. Now, database migration service components include things like connection profiles. This is where we can represent the connectivity information to the specific source that will be used in a migration job. We could also have conversion workspaces that helps us convert our schema and code objects from the source database to a format that's really compatible with any of our destination instances. Now, conversion workspaces are used for things like heterogeneous migrations as well. We'll also have migration jobs. This represents a source connection profile and our destination, so that a Cloud SQL instance or an AlloyDB cluster pair, along with migration-specific settings for those two things, so that we can actually have a job that defines the whole process, such as migrating from MySQL to MySQL in the cloud or PostgreSQL to PostgreSQL in the cloud. Those jobs are going to be defined, and we can reference them later. Now, the database migration service use cases, there's a few different ones, and one of them is known as the lift and shift migration to a managed service. This is one area where I would use a DMS. Lift and shift usually means that we're trying to move from on-premises to Google Cloud. So this is where I can move from a VM-based self-hosted databases to managed databases and cloud services. This is going to allow my team to get out of the business of managing our infrastructure on-premises, and we'd actually utilize the cloud for us. So I just move the data from on-premises into this fully managed database service. I could have a multi-cloud continuous replication. So if I have read replicas across regions, if data exists in another cloud provider, what a migration job can do is it can be set up which continuously replicates the database into Google Cloud, so I can have a multi-cloud read availability. This is where I can use DMS to support this scenario. Now, the Google Transfer Appliance, GTA, is what's utilizing the solid-state drives or SSDs. So this is where I can move data quickly and efficiently, and I can use this service as well if I want to leverage things like SSD drives, which has increased reliability over hard disk drives to make sure that the data transfer is smooth. There's also multiple network connectivity options. I can quickly move data from my devices to our transfer appliance, and I can either use varying networking speeds, including a 10 gigabit per second RGR5 interface or 40 gigabits per second QSFP Plus interface. Those are both supported. And we'll have things like an increased scalability with multiple appliances, so I can scale my transfers by ordering these appliances to increase our transfer speed. And I can also look at globally distributed processing, which will reduce shipping times to and from Google, which ensures the data transfer to cloud storage is very quick. And it's very minimal software that's required. For example, for Linux and Apple macOS systems, I can copy directly to transfer appliance by mounting a simple NFS share on the appliance to my workstation, and then I can use just a simple script to move files from that Linux system into this NFS share. And there's a similar process as well for Microsoft Windows systems where I can copy directly to this appliance using SCP. Now, the Google Transfer Appliance process involves things like requesting an appliance for our business. That's the very first step. So Google is going to work with us so that we have the correct appliance for our requirement. And we get to upload our data by mounting the SSD to the appliance that we're interested in, whether that's Linux and Apple Mac OS system or a Windows system. And then I can ship the appliance back to Google when it's finished. And so this will complete the transfer and seal the appliance. And Google will then upload the data to our Google Cloud Storage bucket and then wipe the appliance when we're done. Now, the Google Transfer Appliance process just means that we're going to be looking at Google uploads the data into this bucket for us. And then after that, once the bucket is ready to go, the transferred data is going to be accessible for us, and we can start using it in our applications. Now, there are some security features built in. For example, our data and network security is very important, so it has to be tamper resistant. So bad actors can't easily open the appliance's physical case. Another thing you'll notice is that it's ruggedized, meaning that the transfer appliance's shipping container is ruggedized, ensuring that data is going to be arriving safely. And then we actually have a trusted platform module, or a TPM chip. So this is where Google can validate TPM's platform configuration registers so that the immutable file system and software components haven't been tampered with. So there's a way for them to check that. And then there's hardware attestation, where they can use a remote attestation process to validate the appliance before you even connect it to your device and copy data to it. A few more security features that's offered through GTA. We can actually use this to ensure our data is safe using AES 256 encryption. So the data is going to be encrypted with this very standard encryption to keep it safe, so no one can actually read the data that's stored there. We'll have customer managed encryption keys as well, so we can actually manage them through the Cloud Key Management Service, or KMS, and we can enable them so that we can control and secure our data prior to shipping an appliance back to Google. Another thing that you'll notice is that it's NIST 800-88 compliant data erasure, so that once the data is stored, we can actually get a wipe certificate to verify that the data has been wiped directly. Now, there's Google Transfer Online capabilities as well. So we can transfer data to cloud storage with very low latency, and we can actually connect to multiple appliances if need be. So this allows us to have an online mode that allows for parallel connectivity to multiple appliances. Here's some Google Transfer Appliance Online capabilities as well. So we can actually have a low-cost, fully managed method for data transferring, and we could have some end-to-end security that's provided during the transfers as well. And the online mode is easy to enable and disable if need be. And so this is just some advantages with using Google Transfer Appliance, as well as the Google Database Management Service. In this video, we're going to describe the requirements and the use cases for leveraging the BigQuery Data Transfer Service. Let's first understand, what is this BigQuery Data Transfer Service? Well, when we're working with an on-premises data warehouse, they're notoriously difficult to scale. Every time we need to scale them, we need to either vertically or horizontally scale these machines. It requires managing the underlying infrastructure. And that can be expensive and time-consuming process. So we ended up having to create a service in Google Cloud called BigQuery. And this is a great technical fit for enterprise data warehouses that can be serverless and highly scalable and cost-effective. Now, the only thing is, now we need to take our on-premises data warehouse solution and migrate them into BigQuery, where we can have this serverless, highly scalable, and cost-effective solution without having to worry about the underlying infrastructure. So this is where we have to be able to migrate information to BigQuery, and this will require things like downstream systems that don't break because of inconsistent results when we're migrating the data. And BigQuery Data Transfer Service has a few different considerations that we need to worry about. There are financial benefits to migrating to open source services. And there is a BigQuery that is a completely serverless big data service that scales based on need and on demand. So if we need more complicated queries, BigQuery is going to handle the underlying infrastructure and spin up more resources for us underneath the hood without us really having to deal with it, so that we can actually get the results for that query. We have additional big data services and analytical tools that can be extended onto BigQuery, so we can actually use those kind of dashboards or analysis tools that could be used for machine learning as well. And we can migrate to a cloud platform that provides scalability and redundancy. So once the data is in there, not only is it easy to scale, but it's also fault tolerant. So in case something were to happen, we have some redundancy built in so our operations can continue. Whereas with on-premises, it's a little complicated to set up some redundancy, let's say. Now, BigQuery Data Transfer Service has a few more considerations. So one of the things I want to know is that moving to the cloud, it provides more data transfer centers for future expansion. And it has some data warehouse migration that requires much planning and implementation time. And you should also know that having a technical partner assist in the migration is quite beneficial. You are going to need some engineers to do this process for you. And this is where having this kind of experienced partner in enterprise data warehouse migration can be quite useful. So selecting the right partner will reduce the technical and financial risks and allows us to plan for and possibly start leveraging long-term benefits in the migration process. Here's a little bit of what the BigQuery data transfer migration architecture will look like. So we start with an on-premises data warehouse, and so there are some files and some sources that we need to identify. So we'll take some of those files from our on-premises data warehouse, and we'll continuously sync them to support various conversions and data validation steps. Then we'll automatically use the on-prem to BigQuery transfer agent for those files and send them over to a cloud storage, which is acting as our inbound or outbound. BigQuery will then do some data quality checks with Dataflow and either send them to BigQuery stage, or we can actually use this cloud storage as a BigQuery load or export directly into BigQuery as well. So there's a few different possibilities that we can use. Using the data quality checks in our Dataflow pipeline is quite useful because then it allows us to get into a BigQuery staging environment. And what we can do then is we can start historically synchronizing our data using Cloud SQL auditing and sending them over to a cluster, to a Kubernetes engine cluster for automated validation and send them over into BigQuery as well. That's a little bit of what the migration will look like and what the architecture is really built on when we're dealing with on-prem data warehouse to BigQuery. Now, the BigQuery data transfer migration architecture involves creating the core components for accessing and working with Google Cloud Services. So we need to set up some foundational elements, which can include the major things that all services would require, such as IAM for authorization and access, as well as billing, networking, and code pipelines. We want to ensure monitoring and security scanning are active before migrating any of our data. So having those services ready to go before any real user data is loaded using cloud operations for monitoring and logging. And we can even use the Security Command Center for security monitoring to make sure that we're not violating any security directives. And so we want to be able to extract data from on-premises servers and move the data into cloud storage. And so this is where we're going to put them and establish an ongoing synchronization using this BigQuery transfer service so that they are stored in cloud storage files. Here's a few more pieces about the data transfer migration architecture. We want to process the data in Dataflow, and we can even load or export data to BigQuery. This allows us to have a few validation steps in our data pipeline to make sure that everything is supported. We want to be able to validate the data using Data Medica's validation utilities, which are also built in. And so you can run these in a Google Kubernetes engine cluster and Cloud SQL for auditing and historical data synchronization as needed. You can also use Cloud Composer to orchestrate the entire pipeline, which is great for infrastructure as code. This is a way we can integrate with on-prem scheduling services as needed to leverage established processes and keep legacy and new systems in sync. Now, the BigQuery data transfer migration architecture will involve things like coordinating with teams that ingest the new data, which is quite important. This is where we have to make sure that our services are ingesting new data into this enterprise data warehouse, and downstream analytic teams relying on this enterprise data warehouse data for ongoing advanced analytics are aware of what's happening. We have to make the data in BigQuery available for reporting, visualization, and application consumption. And we also need to make sure that increase BigQuery flat rate processing capacity incrementally. So this way we can provide the most cost-effective utilization of any resources during the migration. That's a little bit on the BigQuery data transfer migration service and its architecture. In this video, we're going to identify the requirements and use cases for leveraging services such as Dataflow, Cloud Composer, and Cloud Storage. Let's see what it means to integrate other services into a successful migration. Well, how do we do this? Well, there's 3 services that we want to use. We use Google Cloud Composer, which is our infrastructure as code tool in Google Cloud. We have Dataflow on Google Cloud to actually migrate the data from one location to the other, as well as add some transformation steps and some data validation steps. And we have some cloud storage to store some of the artifacts of these files that are generated by Dataflow or the database migration service. Now, the Google Cloud Composer, like I said, just provides access to the Airflow web user interface, and it uses projects that are portable to any other platform, as well as support for hybrid cloud operations. This feature is what combines things like the scalability of the cloud and the security of an on-premises data center so that we can have those hybrid cloud operations available, whether that's something in the cloud and something on-premises. Now, projects are portable to any other platform. So Composer projects you can use them on any other platform by either adjusting the underlying infrastructure. Now, Cloud Composer is very easy for us to use. It has Python support built in, and its seamless integration with other Google products makes it very easy for us to actually utilize it as a great ETL tool. And it has a performance data that's viewable in a dashboard without the need to actually query anything on the command line. You can actually see your infrastructure and how it's performing straight in the Google Cloud dashboard. Now, the Cloud Composer has some benefits that I just want to discuss. Some of them is that the configuration is actually quick and simple. So if you already have a Google Cloud account, all you have to do is just in a couple clicks, go log into the console, configure it right there. And then you also integrate well with Python libraries, and it supports Python 3.6. And what's very useful about this is that you can create what's called a directed acyclic graph. And so this is just a way for us to control what operations happen and in what order. And so the DAGs there is quite useful to have some type of control flow for all of our transformation processes. Now, Apache Airflow has a few different components. One of them is the fact that it has a web server. It's basically what gives us the user interface, the graphical user interface of Apache Airflow. It's used to track the status of jobs, and it actually can be accessed directly in our web browser. We have things like a scheduler, which is responsible for orchestrating and scheduling jobs, and you can have them almost like a cron job on steroids. You just have them repeat on a certain schedule if you're choosing. Now, the executor is the set of worker processes that's responsible for actually executing the tasks that are being scheduled. This is basically the heavy lifters of the whole transformation process. And finally, we have the metadata database. It's a database that comprises metadata that's related to things like our jobs, our DAGs, our schedules, and really anything else that's quite useful for us. Think of it as just a way for us to access logs of the information. Now, Google Cloud Dataflow is very powerful. It's a fully managed data processing service. It has automated provisioning and management of processing resources, and it also uses horizontal and vertical autoscaling of all of our worker resources so that it will handle actually right-sizing all of our machines for us as the job is being executed. Now, the Dataflow has a few different features that I want to discuss. One of them is it provides a real-time AI functionality. So this is quite useful for this. So it has enabled through out-of-the-box machine learning features. This is where I can interface it with NVIDIA GPUs and ready-to-use patterns. This real-time AI allows for real-time reactions. And so you can use this to train, deploy, and manage complete machine learning pipelines, including things that are done on the local and remote inference with batch and streaming pipelines if available. We also have auto-scaling of our resources so that we have the optimal use of resources and jobs. And there's monitoring and observability built into place for all of our services. So I can actually see each step of a data flow pipeline and diagnose problems and troubleshoot them effectively with some samples of actual data. And then finally, we have Dataflow ML. This is a way for us just to deploy and manage all of our ML pipelines very easily. I can utilize machine learning models to do local and remote inference, and it's all done in this space. So that is what Dataflow offers, as well as what Airflow and Cloud Composer offers. In this video, I'm going to talk about validation of our data migrations. So why do we have to validate a data migration? What's the purpose of doing it? Well, when we validate a data migration, what it's allowing us to do is prevent disruptions or downtimes that could be caused by the migration. It allows us to verify the system that still works correctly with this migrated data that we've moved either from on-premises and into the cloud. And this is where we first have to identify any issues which can be fixed before migrating to production. And it's basically a way just for us to do QA of this ETL that's been done. It could be a massive ETL from all the data that's stored on premises and in the cloud. This is where we'll have data migration that has some best practices to ensure that we're not violating any problems that could be seen by a customer. We want to define data validation rules and thresholds. This is really important for us to make sure the integrity and accuracy of our data is correct. So we have to define these validation rules and thresholds because we can't move any critical business data to a new system if these validation rules need to act as a checkpoint for our data. So if they don't pass those checkpoints, then something is wrong. So once we set those up, they have to be kind of tied to our business use case. So it depends on the data that we have to validate, but we need to agree to them before we actually start any migration. And then we have to identify data that is inconsistent and that has any gaps. Finally, the last couple of things I do is make sure that we have data cleansing and normalization in place to make sure that our data is correct and it's not repeating itself. So once we've identified these inconsistencies and the gaps that are cleaned, now we can actually enrich our data and we could standardize and fill in these gaps. And so this way, our data is going to be accurate and reliable. And finally, we have to establish the post-migration quality assurance process. So now we've cleaned our data, we have identified some gaps, and we've defined our validation rules. The final thing we have to do is establish the post-migration quality assurance process, meaning that we have to do some type of QA on the final product that is in the cloud, assuming that you went from on-premises to the cloud. And so this is where you'd have to do some QA to make sure that everything is behaving appropriately. Now, these test processes involves cleansing the source data to remove this duplicate or historical data and any garbage data, or sometimes redundant data needs to be removed. This will determine the process and services for our data migration, and then we need to back up the source data before any data migration at all. The source data is basically going to be our ground source of truth. We want to keep that in a safe spot while we do some work with this data to transform it in this new layer. Now, a couple of things that I do is I'll examine and map the source data to the target system. This is where we'll actually create these transformation layers, and we'll have to have a detailed step-by-step process on how to take the data from this location to the other location. So this could mean maybe I need to change some timestamp formats, or maybe I have to change what's actually being stored in a column, what types of variables are going to be stored in a column. And once I have this all defined, I need to then run a sample of data migration to the testing environment to make sure that my transformation is working properly. All of the use cases and edge cases that I can come up with to actually map this source data to the target system. Once this is ready and it's passed a small testing environment, then I can complete the data migration by running it all the way through. Now, the data migration validation and testing procedure make sure that our data quality needs to be validated. And this is where, again, it's going to be dependent on our business use case. What is exactly considered quality data for one business use case might be different for the other. So you have to have that already defined. So you have to also migrate data needs to be validated to ensure that it's not mismatched between the target system and the source system. And your data needs to be validated to ensure none of it is lost. You don't want to make sure that you've lost any type of data at all that could be important for machine learning purposes. Now, data migration, validation, and testing, make sure that we have some sample data that should be taken either from a live stream or for some type of testing purposes. And then we have to have real-time environments that should be replicated for testing our migrated data. Finally, I'll make sure that my automation tools can be used to generate sample data to simulate expected data volumes. Now, the reason why is because we're testing with a small amount of data, which is fine, and we know that the logic is correct and that there's not going to be any errors. Now, if we've tested with a small amount of data, we want to make sure that our pipeline is going to scale properly when we use a large amount of data. And this is what these automation tools can be used to help us simulate this expected data volumes to see how our pipeline is going to behave. So that's a little bit on data migration, validation, and testing. In this video, we're going to describe how the validation tool enables faster validation of a migrated data set. So here's what a data validation tool can do. So there's a lot of steps to actually validate our tools, to validate our data. And the good news is that we don't have to reinvent the wheel. There's going to be data validation tools that are meant for enterprise data warehouse migrations already in place. So data validation is just an important part of our data migration. And the good news is that a data validation tool can be just an open source Python command line interface tool that automates data validation for us. And if we use this, we might be able to save some time. So this tool works very well with BigQuery, Cloud Spanner, Cloud SQL, and Teradata. And what this Google Cloud integration will allow us to have is it'll allow us to provide a standardized solution to validate data migrated to our Google Cloud. Any data that we're using, for example, with existing infrastructure and extract, transform, or load, or ETL pipelines, can be validated here. This is the idea of using what's known as DVT. DVT provides a standardized solution to validate any migrated data in our Google Cloud against existing systems. Now, this data validation tool with DVT is available for us to use, and it's all open source. So data validation tool can feature things like table level validation. So I can actually validate table by table. I can also look at column schema validation to make sure that each column has the right source, has the right type of data that's stored in there, and it's adhering to certain constraints that I've defined. And there's a row level hash comparison validation as well, and raw SQL confirmation, where I can run custom queries on different data sources. And the thing you should notice here is that the hash level comparison validation can only be run on BigQuery destination targets. And here's the data validation tool connection tools. So the first step to validating our data is creating a connection, and it's done through this command that you see on your screen. It's just data-validation, connections, add, and then give a --connection-name, followed by your connection name, and then give it the type as well as your project ID. It's simple as that. Now you've created your connection, and all you have to do from here on out is use BigQuery and MySQL here. This is a simple validation example, but a similar one can also be used for PostgreSQL, where I can actually run this command on a particular type of column with this connection and list the information. Now there's additional data migration validation tools that are available. So things like schema comparison tools, which are indispensable for ensuring the data structure remains consistent between the source and target systems, even post-migration. And as well, we have data profiling tools. This is an in-depth analysis of existing data, and I use it to identify patterns or anomalies or any type of inconsistencies between the source and target. This step is really important from when we're looking at data pre-migration and addressing any issues that might impact the migration process. Now, there's additional data migration validation tools that include things like ETL testing tools, which validate the extraction, transformation, and loading of our data into the target system. And there's data quality tools that focus on ensuring that the migrated data meets predefined quality standards that I've already defined. This is really important for checking for completeness, consistency, and reliability within our data. And there's data comparison tool, which is great for post-migration validation because they compare data sets in the source and target systems to make sure that the data migration process did not alter the actual content. So that's a little bit on some of the additional data migration validation tools available. In this video, I'm going to communicate the importance and practical steps needed to ensure that data governance is maintained during migrations. So data governance concerns during a data migration are really important so that we make sure that we are compliant with certain GDPR or HIPAA compliance, for example. So this is going to allow us to ensure that data consistency and quality is available There's a standard and policy for data quality, making sure that our data is accurate, complete, and consistent through this whole migration process. Now, this will allow us to manage things like data privacy and security, and this is going to have some type of compliance with privacy regulations such as HIPAA or GDPR. And these industry standards are defining by data access controls, our encryption protocols, and even things like data masking techniques can all be done through here. And it'll establish data ownership and accountability. The whole point of data governance is establishing clear data ownership and accountability so that the responsibilities for data quality, integrity, and management are defined and assigned. Now, data migration, data governance teams will collaborate with data owners and stakeholders to validate and verify the data, and so that it's accurate and complete. Now, the cloud data governance is really important because we have to set of policies for streaming data collection, storage, and cloud usage. This allows us to improve efficiency, minimize our security risks, and improves the quality and usability of our data sets. This is really important for when we're actually working from on-premises to cloud migration tools. Now, cloud governance key principles involves that we document the authoritative sources and our distributors of our data. We need to understand who's providing the data and where is it coming from, as well as establish things like data sovereignty and cross-border data movement. So some compliance, for example, with GDPR, we have to make sure that our data is stored in a particular region, usually the same region that the data was collected. We can't say, for example, store Canadian data in US states. That's probably not allowed, depending on the compliance that you're working with. And so you have to make sure that it is going to be valid during our data migration process. And finally, we have cataloging and classifying data with our metadata. This involves things like data catalogs that are just more than metadata repository or a data dictionary. What they are is just a way for us to continually analyze data and its metadata to provide insight that enables data governance at scale, so we know that we're performing properly. So a data catalog could identify metadata and structural changes in a data source, and we could perform discovery things or classification tagging if need to be. This is the whole purpose of using a data catalog, because it allows us to identify the data about the data that we've collected. Now, a couple things I'll bring up here is that data access control and usage is really important. We can't just have anyone in our organization that could have access to sensitive data. Data should be on a need-to-know basis. So if access to data is not sufficiently controlled, the business could experience things what's called data leakage, corruption of data, or even reputational damage. There is a possibility to also see, in extreme cases, criminal manipulation of business processes. So this data is then at risk of not being fit for its purpose. So it's really important that we identify who are the key stakeholders, who are the people that are allowed to access certain bits of information, and not necessarily give everybody access to our data. The concept of least privilege should apply for every person that has access to our data. So data protection in transit and at rest and privacy is also important. If we're going to be moving data and storing it in a different location, especially the cloud, we have to make sure that there is going to be some type of encryption in place during transit, but as well as when it meets the target destination, it needs to have some type of encryption at rest so that no one can access it outside. And data ownership and management means that sensitive data should never be left unmanaged. So if you're managing data in the cloud and a piece of data has been marked sensitive, it must have an owner. An ownership field capability ensures that our data has an owner, and if it doesn't, someone has to be alerted to remediate it. Now, cloud governance and key principles are important here. So talking about is measurements of our data quality needs to be in place, and this is often most used data governance metric. You'll notice that this valuable information is going to be visible to both data owners and our consumers. This allows our users to see how many times a data set has been entered, how many data values are similar across our entire system. So this measurement of data quality needs to be in place. There's also data retention, archiving, and purging policies. This is all part of the data lifecycle, and it needs to be planned and managed. This means that organizations should know where sensitive data exists, how long it should be kept, and its requirements for keeping it stored. So once we have this, it's important for future audits, because if we don't follow this data-specific jurisdiction, it could result in legal action for our jurisdiction. Now, the origins and lineage of the data is also important. We have to be able to trust the data that they use, not because the data accuracy is important, but because the cost of producing incorrect data is quite significant. So we have to have what's called data lineage. This is a way for us to understand our data. It helps us determine things like its suitability for our usage, identifying where it's coming from. It does this by sharing some of its details, like how it's changed over time. For example, I get to see how this record in my database has evolved from extraction, ingestion, to transformation, whether that's multiple transformations, to the insertion into this target system. That's really important for me to see how it's behaved. Now, data governance has some benefits. It's not just some legal jargon that we have to follow. It allows us to get better decision making when it's available. So users throughout our organizations get the data they need, and it allows us to service customers, even design and improve products and services. We can increase data control efficiencies as well. It helps us manage resources more effectively, and we can eliminate things like data duplication that's caused by information silos. So you don't have to overbuy or maintain expensive hardware that you may not need, and it's not driving revenue for your business. There's also data governance and benefits as well that increase regulatory compliance. So this makes it more important for organizations to establish robust data governance practices. This way we avoid risks that are associated with non-compliance and legal implications for our organization. It increases the levels of trust with our customers and our suppliers, and it allows us to increase risk management and data across data access control. And finally, we can ensure that the correct people have access to the data they need. If we follow the principle of least privilege for even with our data, not just our infrastructure, we'll make sure that our data is compliant and that there's not going to be any data leaks or any problems with data access. And that is a little bit on data governance and its benefits in the cloud and on premises. So in this course, we've examined how to design and execute data migrations, leveraging cloud services, validating data, and addressing governance concerns. We did this by exploring planning data and validating a plan for migrations, database migration service, Google Transfer Appliance, and BigQuery data transfer service, integrating other services into a successful migration, validating a migration, the data validation tool, and data governance concerns.